Alright, so what we're going to be doing here is we introduce the concept of a limit. I first of all want to start with a definition of a limit. And students sometimes struggle with limits a little bit because there's a level of uncertainty. It's not as necessarily concrete as some of the other things that we've done in mathematics. Take a look at that definition of the limit. And what word kind of jumps out at you?
Approaches.
Okay, that's actually the key word right there, approaches. Okay, that's where this uncertainty comes from. That kind of bugs students sometimes. All right, if we read the definition, it says, if f of x becomes arbitrarily close to a unique number L, in other words, the y-coordinate is approaching a value L, as x approaches c from either side, the limit of f of x as x approaches c is L. This is written as this notation here, okay? So you'll notice here this word approaches occurs twice. And this clause right here, the limit of f of x as x approaches c is L, is exactly how you would read this equation right here. The limit of the function f of x as the value of x approaches c is L. Okay? Now I gave you a little piecewise function here to illustrate this with. But you'll notice it says here, it says x approaches c from either side. So let's actually look at this piecewise function and see what happens here. Okay? We'll zoom in a little bit. You'll notice here we're trying to find the limit as x approaches 2. So in that definition, the c that they were talking about is this 2. Okay? So this is what we are approaching here, is this x equals 2. All right? Now, we need to approach this from both sides. So as we approach from the left, x approaches approaches 2 from the left. Let's look at our y-coordinate, okay? All right, so our y-coordinate, if we start on the furthest left point that we can see, our y-coordinate's way up here, and as x is getting closer and closer to 2, notice it's going down here for a while, it reaches this lowest point, now it's starting to come up. What value is the y-coordinate approaching as we get closer to 2 from the left?
0.
It's approaching 0, okay? It's getting close to that value of 0, okay? Now, we can also approach 2 from the right. Okay, x approaches 2 from the right. So again, let's look at this. Let's go to the furthest right of this graph that we can see, and you'll see we're up here. Now it's decreasing as we come back towards 2, and what value is our y-coordinate getting closer and closer to?
0.
It's getting closer and closer to 0 again, all right? So what we would say in this case is that we're approaching 2 from the, or 0 from the left. The value is approaching 0 from the right as x approaches 2. Therefore, the limit as x approaches 2 of f of x is 0. Okay?
Why are both approaching things the same at the bottom?
Well, this is approaching from the left. This is approaching from the right. We're getting closer and closer to 2 from either side.
Oh, that's just like like to show you. Okay.
Yeah, I'm just showing you kind of what we're doing with the x value. We're getting closer and closer, okay? And that L that was in the equation, or up in the definition, that's this 0. The function is approaching that value 0, okay? So we have this idea of approaching x equals 2 or x equals c from either side. And those two approaches actually have a name. Okay? Actually, they have their own names. We have two types of limits that are used to find the actual limit. All right? We have what's known as a left-hand limit and a right-hand limit. Okay? The left-hand limit and the right-hand limit. Okay? The limit as x approaches c from the left is approaching it from values that are less than c, because that's to the left of c on the graph. Okay? The notation we would use is we would say the limit of f of x as x approaches c, and then we put this little superscript negative sign there. That means that it's approaching c from the left-hand side. Ahmad?
Can we go back up for a second? Repeat question.
So that's the limit from the left-hand side. What do you think the notation is going to be to get the limit from the right?
The positive.
Yeah, okay. The limit of f of x as x approaches c from the right. That's from the positive side. If you think negative x-axis and the positive side of the x-axis, it makes sense. Okay? We're not trying to be tricky here. All right, but this is how we are able to evaluate limits using a table. Okay? Now, if we look at this graph right here, we have the function x over the square root of x plus 1 minus 1. And you'll see there the graph of that function. Okay? You'll notice there is a hole in that graph. Okay? Now, this is what's cool about the limit. We can still find the limit as x approaches 0, even though the function is undefined when x equals 0. Because it doesn't matter what the function equals, it matters what the function is approaching from either side. Okay? Question?
Why? Well, I mean, I don't know. Why did the x values have to be so close to 0 and not be like 0, 1, 2, 3, and negative 1, negative 2, negative 3?
Well, that's a good question. The reason why, as you can see in this table, we start at negative 0.01, then negative 0.001, negative 0.0001, we get exponentially closer because we want to see what it's actually approaching as we get super close. Okay? If we did it linearly, like if we did negative 0.03, negative 0.02, negative 0.01, we may not be getting close enough to really see what it's approaching. Likewise, if we got too close, like if we did negative 0.0003, negative 0.0002, negative 0.0001, we might be so close that we can't see the trend of what it's getting close to. Because as we'll see later, sometimes we'll get ones that don't actually approach any specific value. They kind of bounce around all over the place. And so we would say the limit doesn't exist because it isn't actually honing in or approaching any one value. So that's why we need to start a little bit of ways from it and get exponentially closer. That's an excellent question though. So let's look at how we would do this. First of all, looking at the graph, what does it look like the limit is going to equal? 2. Okay? If you were to look at this, as we come from the left, and as we approach from the right, here's x equals 1, here's x equals 2, it appears as though this limit will equal 2. Okay? Now, just eyeballing a graph is not quite good enough for what we want to do, so we're going to use the table. Alright, so how do we fill in this table? I want to give you an efficient way of doing it. This is where you could do it the long, hard way or a much simpler way, okay? And there's actually quite a few ways you could do it, even with your graphing calculator. But I want to show you what I feel is kind of the most efficient way of doing it. And that is by, first of all, graphing it, okay? Let me bring this up so we can see. You'll notice here I hit y equals, and I went ahead and I typed in the function that we have. Do be careful that you type in the function correctly. Obviously, if you don't have the correct, oops, I hit clear. If you don't have the correct function, then you're not going to get the correct limit. So x divided by parentheses, the square root of x plus 1, take that out of the square root, minus 1, close your parentheses, and there's your graph. Okay? So, now we hit graph, and you can see here, that kind of looks like the graph that we were just looking at. Now, at this point, some people like to use table set. All right? Personally, I prefer to use trace. The reason is this. Table set is good if you want to look at the change as the x changes linearly. So like the 0.03, 0.02, 0.01. But when you want it to change exponentially, it's actually kind of a pain to use the table. So, if you simply hit trace, remember you can type in a value for x. Now notice here, when I hit trace, x equals 0, it didn't give us a value for y. That's because it was undefined at 0. Okay? But let's first of all type in negative 0.01, and we get a 1.9949874.
Do you hit enter?
Okay, yeah, type in a negative 0.01, hit enter, and you can see we're really, really close there. Now, the other thing here is I don't want you to round very much. Give yourself at least 4 or 5 decimal places. Okay, so this is 1.9949874. Okay, so 1.9949874. Okay? Now you keep doing the same thing. We're still tracing here, so if we just type in negative 0.001 and hit enter, it gives us 1.9994999. Now, does it look like it's approaching 2? Okay, it kind of does, but let's go one more step. Let's type in a negative 0.0001, and we get a 1.99995. Okay? So here, it appears as though it is, in fact, approaching 2. However, what did we just find?
The other side will approach it also.
That's what we need to find, that's
We
right.
found the
Left-hand
negative
limit.
side.
We just found the left-hand limit from the negative side, okay? So we just determined that the limit of that function, I'll just use f of x for simplicity, as x approaches 0 from the left equals 2. Okay? Yes?
So how would you ever know this if you didn't have the graph? Would you just keep getting smaller and smaller until it would never equal 2?
Well, I mean, we're down to the negative 1/10,000th away from where we want. So we can kind of see a trend. We're getting more and more 9s every time we get closer. So we can, you are approximating here with the table. We will look later on at how we could do this algebraically to get exactly 2. Okay? But we're going to work up to that first. Okay? Alright, so let's do the right-hand side. We need to also figure out what the right-hand limit is. The limit as x approaches 0 from the right. Okay? What do you get when you plug in a 0.01?
2.004986.
49876. Okay? Good. So you get that when you plug in a 0.01. How about when we plug in 0.001?
2.00049.
Okay? And then finally, if we plug in a 0.00001.
2.000005.
Okay. So notice here we're getting more and more zeros after the 2. The closer we get to 0. So we can say that from the right-hand side, we're approaching 2 as well. So since we're approaching 2 from the left and the right, we can say, like we thought originally, that the limit as x approaches 0 is indeed 2. So, the question Ethan just posed is actually what we're going to look at right here. And that is, what happens if the left-hand limit and the right-hand limit aren't the same? Okay? And really what we're looking to answer here is, does a limit even exist as x approaches a value? And there's really a 3-step process that you have to go through to determine whether or not the limit exists. Okay? First of all, the left-hand limit must exist. Secondly, the right-hand limit must exist. And thirdly, the left and right-hand limits have to be equal. Okay? We're going to look at 2 examples here where the limit does not exist and see why. Okay? Notice here, I have another piecewise function, and on this piecewise function, I'm following this parabola from negative infinity all the way up to where x equals 2. Okay? And then once I pass 2, I'm jumping up to this line, 1/2 x plus 1. Okay? So let's think this through. As I approach x from x equals 2 from the left, I'm way up here, then I'm coming down, I'm coming down, I'm coming down, down, down. I've reached the bottom, now I'm coming up, I'm coming up. What is f of x approaching as x approaches 2 from the left?
0.
It's approaching 0. Not as you go to the left, but as you get closer to 2 from the left. All right?
Once you get closer to the left,
So we're getting
on the
closer to
x-axis,
2. Yeah, on the x.
We're getting closer to 0 on the y.
That's exactly right. As we're getting closer to 2 on the x, we're getting closer to 0 on the y. Okay? Now, let's look at our right-hand limit. If we go to the far right-hand side and we start coming back towards 2, it's decreasing, decreasing, decreasing. What is it getting closer and closer to? It's getting closer and closer to 2. Okay? So, does the left-hand limit exist?
Yeah.
Yes. Does the right-hand limit exist?
Yeah.
Yes. Are they equal?
No.
No. So, we would say that the limit as x approaches 2 of f of x does not exist. Okay? The limit does not exist. Alright, so we would just put D, N, E. Okay? And of course, that means does not exist. I'm having a little trouble spelling today. Alright, does not exist, DNE. Okay? Do not put undefined, do not put no solution or something like that. You need to use the proper terminology, and that is that it literally does not exist. Okay? So that's one example where it doesn't exist. And that's where the left and right hand limits do not exist. Here, I actually have it already worked out, but let's look at how this works, okay? Here we have our square root parent function, all right? F of x is the square root of x, and you guys know that the domain of that parent function is that x has to be greater than or equal to 0.
Yeah.
Now, if I wanted the limit as x approached to 0, I would need to look as it approached from the left and as it approached from the right. Okay? And as you can see here, when we approach from the right, it's decreasing, decreasing, decreasing. It's getting closer and closer and closer to 0. Okay? However, what's true about the function on the left-hand side?
Every value
Doesn't
over
exist.
0 is undefined.
It's undefined. You can't approach from the left. So if you can't approach that point from the left, then it's not approaching anything from the left. Therefore, the left-hand limit does not exist. So we would have to say that the limit as x approaches 0 does not exist. Okay? So here's kind of a general rule. If you're trying to find the limit at an end point of a function, like we have here, the limit's not going to exist. It'll only exist from one side or the other. Okay? So that's another case where the limit does not exist. Okay. So, finally, to wrap this whole thing up here, okay? If a limit will not exist, there's a couple of particular patterns that we can see. One is what we just saw, where the left and right hand limits are not equal. Okay? We just saw that with that piecewise function. Okay? And that would include when one of them doesn't exist. Okay? Because obviously if one doesn't exist, then they're not equal. The second option here, you will see varying opinions. And really, neither of them is right or wrong, but we are going to use the point that they do not exist in number 2. The function increases or decreases infinitely as x approaches c. I've given you the example here of this function 1 over x squared. It looks like this. If I were to find the limit as x approached 0, you can see here it's going up to positive infinity as we approach 0 from the left. And over here, as we approach from the right, it's going up to positive infinity. Now, here's where the difference is. Some people, okay, and actually this is what I learned in my college class, so even universities disagree on this. They will say the limit approaches infinity. Okay? Nothing wrong with that. Other people, kind of the more purist idea, is that a limit has to be a specific number. And since infinity is not a specific number, we would say that the limit does not exist. That's what we are going to use in this class, partly because that's what IB and AP both use. Okay? So if you go on next year to IB or AP, you'll be all set. Okay?
Which one do we use?
We're going to use does not exist. So if you see this, okay, technically, depending on what you read, you'll either see it saying that the limit approaches positive infinity, or you'll see them say it does not exist. We are going to opt for this and say it does not exist. Okay? And I do want you to put that. Okay? Just get into the habit. Okay? Yeah. You can remember it, think of infinity as limitless.
Yeah.
Alright? So, it does not exist. That's a good point, though, yeah. Now, the third one is really not very common at all. We will actually look at one example of this later on. But this is a case where you have what's known as oscillating behavior. Now, when you hear oscillating behavior, what kind of comes to mind? Waves, like trig functions, right? When you have, now, not every trig function is going to be oscillating behavior. What we're talking about here is not just there's a pattern going back and forth, but actually it oscillates and it's also undefined, and it never is actually honing in on one specific value. Okay? So and also another thing is that it has to be oscillating between two fixed values. You'll have sometimes when it's oscillating and it's getting smaller and smaller and smaller and then bigger and bigger and bigger. That's not what we're talking about, because those aren't two fixed values. It's getting skinnier and then wider. Okay? We're talking about something where it literally is oscillating between the same two values, back and forth, and there's points in there where it's undefined as well. Okay? Like I said, does not happen very often, but we'll look at one anyways just to see it happen. Okay? All right. Now, I have given you some practice doing the table, finding a limit by the table. I want you to practice using proper notation as you do it, okay? Don't just be sloppy, but actually use proper notation as you complete those tables and find those limits, okay? All right.